Right, this is lesson 6 of Unit 2 on properties of congruency. Just remember that congruent means equal in size and shape. So we've talked about that before, but keep that in mind for this unit. The first property we want to talk about is our reflexive property. So when a quantity is equal to itself, angles could be reflexive, sides could be reflexive. In this picture, OB would be equal to OB. Just means that the side is equal to itself, and you'll sometimes need this in a proof. Your transitive property means that if two quantities are equal to the same quantity, then we know that they are equal to each other. So in our picture, if AB equals BC and BC equals CD, notice that the BC is overlapping. So then we know that AB equals CD. The symmetric property is if a quantity is equal to a second quantity, then the second quantity is also equal to the first. So if AB equals BC, then we know you just flip it, BC equals AB as well. Your substitution property of equality. A quantity may be substituted for its equal. So in the picture here, in the example, if DE plus CD equals CE, and we know that CD equals AB, then we're just going to plug AB right in for CD, and you get this statement DE plus AB equals CE. Algebraically, let's say we know that x equals 4, and we're given the equation y equals 2 times x plus 3. Then we can say, okay, y equals 2 times 4 plus 3, and you can substitute in and get that y equals 14. We're going to look at an example of a proof together. When you're working with a proof, you always want to look at your given first and see what that tells you to write a statement and then your conclusion. In this case, I did tell you the number of steps, but that will not always be the case. So our given here is that M is the midpoint of AB and MB equals BC. So first, M is the midpoint of AB. That tells me that AM is equal to MB because we know M is in the middle. So your statement is going to be that AM equals MB. Our reason is definition of midpoint. Now if you look, we have that in our given, MB is equal to BC. So our statement, AM is equal to MB, and now we have MB is equal to BC. So by our transitive property, we can now prove what we are trying to prove, that AM is equal to BC. All right, we're going to do one more example together. In this given, we're told that AC is the angle bisector of angle BAD, and AD is the angle bisector of angle CAE. So the vocab here that you need to know is angle bisector. Angle bisector means that it cuts the angle in half. So if you look at the picture, AC is the angle bisector of angle BAD. That means that angle BAC is congruent to angle CAD. So my statement number 2 is that the measure of angle BAC is equal to the measure of angle CAD, and that is by definition of angle bisector. And that's with the AC. You don't have to write that in, but just so that you know which one we're referring to in our given. The next statement then, in our given, AD is the angle bisector of angle CAE. So if you look at the picture, that's your angle CAE. So that tells you that angle CAD is equal to angle DAE. So the measure of angle CAD equals the measure of angle DAE, and that is by definition of angle bisector. And this was the second given, so the bisector segment AD. Now if you look at what we wrote, we have this overlapping measure of angle CAD. So by our transitive property, we can say that the measure of angle BAC equals the measure of angle DAE. So measure of angle BAC equals the measure of angle DAE, and that is our transitive property. And then the last thing, it really wanted us to say that they're congruent, and we know that equal means congruent. So I can go ahead and say that angle BAC is congruent to angle DAE by definition of congruent.